Hello everybody, so I am currently doing this cloud bootcamp. It's government funded cloud bootcamp and I feel like the information is wasted if it's just on me and the people picked for it. And I thought, okay, I will code along with you. Not show you the material obviously because I bet there's some copyrighted stuff. I was thinking maybe I should upload the videos from the bootcamp, but it's a bit wrong because it's their material. But I can definitely go through the material myself with you guys, possibly make a few portfolio projects, and I can give you the information for this bootcamp whilst I do it myself because I kind of screwed up technically a few times, and so I kind of need to go through everything again. But I'm just going to go through the Docker, Kubernetes, um, what else is there? AWS. No, we're doing Azure. Sorry, Azure, that kind of stuff, and security as well with all this. And hopefully this will give you some fundamentals for how to go about, and how I problem solve and work my way through all this. It's not too hard. Basically, um, need everybody. I'm going to be using Ubuntu and on a virtual machine, and I highly recommend everybody else do that as well. To get a virtual machine, you need software called VirtualBox, and yeah, if I was to give you one video just to get VirtualBox and Ubuntu, it would be a video by, what's it called now? It's on Free Code Camp YouTube channel, and it was some black dude, and he taught you how to use Linux with Ubuntu, and it was a really good video. Works, and big up to that guy. And so that should help you get started with getting into Linux. You're going to use Linux because you can definitely run it on Mac. I think Mac is probably the best way to do it. Just less configuration, less hassle. Windows, be careful because on the official Docker website, they give you an older version of Docker, but if you read the patch notes, there's a newer version, 17.00, which actually works because the version on their site doesn't work. There's like a bug, and if you dig around, you can find a newer version and it'll work. But what you have to also do is Windows subsystem for Linux thing. Just install that too. It'll be on the Docker documentation. It's not super hard, guys. Don't worry about it. But ideally, Free Code Camp, install Linux on a VirtualBox. That's what I'm doing anyway. I will show you my VirtualBox now. Where is it? Boom. Here we go. Let's start it. Did I already started this? That's not good. Oh, I've already started it. Great. So this is my Linux. Oh, cannot show you the stuff, but I will show you my own way. So we're going to be working with containerization with Docker first, okay? And what this means is, first we need to learn about the cloud context. And so you have like software as a service, right? Stuff that other people manage. Let's just work with it like that, okay? And software as a service, it's just like, let me snippet all this to you, because I've got the worksheet, but I can't show you the worksheet. Where is it? Here we go. So here we go. This is the cloud context. First of all, we're here. So imagine you're using Google Cloud. This is it. You're using Google Cloud as a service. Don't worry about all these applications, data. You can figure that out on your own. Just pause the video, figure it out on your own. Well, that's just you using a software. Then there's platform as a service, and you see the blue that's highlighted. That's like if you're a developer, right? So you work with the applications. So you might use JavaScript, HTML, CSS, and yeah, the data, MySQL, that kind of stuff, and you push that onto the cloud. Boom. You talk to your DevOps guy, your cloud guy, and they do the next. Well, that's platform as a service. You using a platform to put your application up there. And then there's infrastructure as a service. Infrastructure as a service, right? This part here, this is what we're working with right now. So infrastructure as a service, this is like Docker. So you're going to be working with the code, making sure the code works on these cloud systems, okay? And yeah, so you'll be working with the runtime, the middleware, and the OS, the operating system, make sure everything works. So that's what I'm going to teach you. So today it's going to be about containerization, infrastructure as a service, that third tier of the stack that I just showed you, and it's about Docker. It's a containerization platform that allows you to create, deploy, and run cloud-based applications in containers. So developers are going to make apps, and you're going to put them in these things called containers. The app in a container, and you're going to put it in the cloud. That's it. That's it for now. And throughout this whole course, I'm going to teach you about all sorts of Docker concepts like Compose, Swarm, Kubernetes, Oracle Cloud, Azure, probably not Oracle Cloud, I mean Azure, definitely. Using VS Code for working with your code, and CI, CD, continuous integration, continuous development, and security and other best practices, So today, let's just work on the basics, container basics, and the objective of this lesson is going to be a conceptual understanding of Docker's images and containers. You'll learn about these images and containers as we go along, and you're going to install and test prerequisite software for the remainder. So let me first teach you about virtual machines. This is these things I've been talking about, containers. I'm going to talk to you about the Docker ecosystem and running like a container. So let's first talk about virtual machines. So I told you to install, pause it, go to that guy on FreeCodeCamp. I'll link it below, and we're going to talk about virtual machines, right? So virtual machines could be like that virtual box I showed you, right? And I'll give you a quick overview. Where is snippet tool? Right. Where is it? Here we go. So this is the review of like what a virtual machine is. So you know how you have Windows or you have Mac, what do you call it, for Mac OS? I think it's called Mac OS, I don't know. And you have Linux as well. So virtual machines, like this virtual box you have running Linux with and everything, they emulate full on OSs, and they run on top of this thing here. So you get the hardware, your actual PC, then you get this thing called the hypervisor, which is a visualization layer, and it has like the bare metal, which is the hardware, and there's this other part of it called the hosted software, the OS. Okay, I hope that makes sense. And that's just what a virtual machine is. It's nothing super fancy, it just runs another computer within your computer. And there's loads of pros to it. So it's isolated. So your virtual machine you're running right now is isolated from your actual machine. So if that thing gets hacked, your actual machine's still fine then, because it's separate. It's a separate entity. It can be compatible with any OS and application. It has virtual networking capabilities, and it has application level management. So yeah, and it has a perceived stability to it. Just run up a new one if anything goes wrong. But there's some cons to it as well, guys. You know what, I'm gonna just snippet you guys just so you have a better understanding. Maybe you can maybe I'm not explaining it great, but here's the pros, okay, of virtual machines. And then the cons of virtual machines. So if it shows it, there's a lot of resource overhead because you need a whole other machine to run a virtual machine. There's like a bit of complexity to it because there's a machine inside of a machine. Now you need to know what's going on inside of this machine. It can be a bit slow because it's like you're running a virtualization of an actual machine, so there is a bit of slowness to this, and as a result it's less agile, and there's scalability is compromised as a result as well. Okay, now I want to talk to you guys about this next part. I'm sorry about this weird structure I'm going with. I'm kind of new to this whole YouTube teaching thing. I'm not going to do it often, I'm just doing this one time. It's just for the sake of it. Docker containerization, just for me as well as you. I'm learning as much as you guys. And so let's talk about Docker containers, right? yeah, let's talk about Docker containers. So, there we go. Containers run in the host OS. So, not this. Okay, we're gonna go to a server, right? Not this virtual machine. Forget about this virtual machine. Imagine we have a container, and this container is going to run in a machine somewhere in America where Azure is, and that's where it's running. Okay, it's going to run. So imagine any computer can be a server, right? Your computer right now can be a server, and we can run these containers in the server. But what is a container? It's like a virtual machine, but it's not. Okay. So on the left, well, I'll tell you the difference between virtual machine and container, right? So on the left is virtual machine, on the right is containers. So they both have hardware, OSs, hypervisors on virtual machine, but not here. In containers, they have container orchestration engine. So for Docker, they have something called Debian. That's what that would be, but container orchestration engine is a difference, right? So this is where it stops. And a hypervisor emulates an OS, like we talked about before, and the OS does the binaries, it gets the libraries for the code we need to run, which makes the applications. But containers are slightly different. They have this engine running with the operating system you already have, right? Nothing to do with this virtual box nonsense that we're doing, alright? Just hopefully that doesn't confuse you. So we're on your Windows, just no virtual box or anything, just your Windows. Imagine that. And this engine is working on top of your Windows device, and it, through this engine, makes the binaries which allow for the binaries. Think of it like the ones and zeros that allow the libraries to work, which allow the application you're trying to build, the developers are trying to build, to work. And that's a container. So a container is made from this engine, the Debian engine, and yet binaries are made, libraries are made, applications are made. It removes this whole, look in the virtual machine part, it removes the whole hypervisor, making a whole other OS. Like, imagine you have Windows on top of Windows. It's just like, what, so much resources. But here it's just engine. You have your Windows, then you have an engine that makes a container. It's like the same thing, but not really. These things aren't competing softwares. I mean, you can have containers in virtual machines. You can do that. So they're not competing, but we're just like, you use one for another kind of scenario. Okay, cool. I think if you want to learn more about it, go to somebody else. But it's pretty straightforward. Basically, containers are like virtual machines. They just virtualize an environment, basically, that you need. Right, this is the next part of the demonstration. So container architecture, guys. It's like a VM. Containers. They run multiple applications on a single physical host. Yeah, makes sense, right? They both can do that, but unlike them, they share the same kernel. So you have the same OS and operating system with the host machine. So they're isolated by the container engine from host and other containers, and are very small. There's no additional OS required, like I mentioned. Let's talk about the pros of having a container. Okay. There's lower resource overhead. You know how I mentioned that the OS is on top of the OS in a VM? Well, we don't have that right here. Containers share the same host operating system and kernel. Like I mentioned, requires less memory and disk space compared with VMs. Makes sense. There's sorry, I've got an itchy nose, I don't know why. There's faster deployment time as a result. There's improved portability, because you don't have a VM stuck on a machine, right? You just put it on. You can put it onto this thing called Docker Hub. We'll talk about it later. Easier scaling, easy replication and deployment across multiple hosts. I think that's where this thing called Docker Swarm comes in, where you can allocate resources for your containers, which is pretty cool. Just like an insane way of improving scalability and stuff. Consistent development and deployment. Consistent runtime environment can reduce risk of deployment issues. So this is where the strength of Docker comes in, where it's like the last point, I mean, consistent development and deployment, where you're running a specific version of an application. For example, if you're running Node 2.555, whatever, in order to run Vue.js version 5, whatever. I've had this problem where I've had a specific version of Vue and I uploaded it onto a cloud software, and then the cloud software updated their version of Node, so my Vue app no longer worked. And if I had something like Docker where it was in a container, it's like, alright, hey, we're sticking with this version of Node, this version of Vue, we're sticking with it, then my application would still work. Maybe I'll remake that application one day. But yeah, I've experienced the problems of uploading your application to the cloud and it not working. And what are the cons of containers, guys? Are there any cons? It sounds too good to be true, right? Is weaker isolation, which makes sense. It's not its own separate OS like with virtual machines. There's a risk of a security breach in one container and how it affects others on the same host. There's limited access to system resources like CPU, memory, compared with VMs. Makes sense, because it's asking for the system resources from the big daddy, the actual kernel, right? The actual OS, whatever. Lack of compatibility, such as specialized OSs or specialized hardware. ARM versus Intel. I've only worked with ARM, I believe, in this course, so I've never come across this problem, but it exists. Keep it in mind. And there's an evolving ecosystem which isn't as mature, so this whole Docker thing could face licensing issues, which isn't really that big of a knock. It's a maturing thing, isn't it? So let's talk about Docker. A summary of what Docker is. So Docker is open source containerization platform, which is basically just a VM Lite. Let's call it VM Lite. It allows the developers to easily create, deploy, and run applications in these things called containers. So you're not creating applications as software developers. You're going to be deploying code onto the cloud. That's basically what it is. And containers are lightweight, portable units of software that package up all the code, get all the developers' code, libraries, and dependencies to run an app. It's like a layered file system, by the way. So this is the next slide. Testing, 1, 2, 3. So this is how the containerization works with Docker. So it's a layered file system, allows the reuse of common components across different containers. So you have your container, right? So image 1. So image just means, hey, this is how I've started this. So let's say I want React.js as the base of everything. That's what image 1 is. And on top of image 1, hey, I want to add Apache. So make image 1.1, and then on top of image 1.1, let's add Git. That's image 1.2. Image 1.2 add source, whatever that is. So that's basically how it goes, and it's all inside the container. So here's the next slide for you beautiful people. So base image plus customizations. So we all have the kernel, which we've established, which is your PC. Let's just say it's the PC. And we reuse existing base images needed to run applications. So these, the orange and the blue, they're separate containers, right? One of them has BusyBox, one of them has Debian, and they're just adding stuff. So the BusyBox container is adding this writable thing. This Debian container is adding one thing, then it's adding Apache, then it's adding writable as well. It adds new customizations if they're required, and the orange container and the blue container, which is both on top of the kernel here, they can both work together there's things in Docker which they can communicate together with, but they are their own separate containers, say separate VMs, lights, VM lights. That's what we're calling them. Containers are VM lights, basically. It'd be so awkward in the future if there's something called VM light which competed with Docker, and this whole thing didn't make sense. Hopefully it doesn't. So, going over the bootcamp's going over what we're going to learn in order, but I'll surprise you guys. Why not? This is very informal. I'm not an expert on any of this. I don't know why you're listening to this, but maybe we can learn from each other. Okay, let's talk about the Docker engine. So, here's the Docker engine. So, we're gonna, don't worry, I will show you how to install Docker. But the Docker engine, you use the Docker command in your terminal, and that will do most of your Docker stuff. To be honest, the core components of Docker that runs the host on the host machine. So I'm going to run it on my Linux, okay, the Linux virtual machine. So pretend that's my main machine, even though it's not. But use your brain. We're using the VM as our main machine for this course. It manages the creation and running of containers using this core Docker keyword. Includes a server that listens for API requests. See, I'm thinking because I don't know the answer either. Includes a server that listens for API requests. So the Docker goes to an API, which is the server which does our commands. It includes a command line client that communicates with the server. Okay. We're using the command line. But there's this whole desktop app, we don't need to use it. I mean, it's better if we do. It's not better if we use it, we don't need to use it. We're old school, we're hardcore. I mean, I did most of the course without it, so I don't think we need it. It's nicer, to be fair, but whatever. And let's talk about the Docker file. This is going to be the main file in whatever application you're making. So imagine we're making a Vue.js application. This will be in the main root folder for that, and it's going to specify a bunch of stuff that we need so we can run this Vue.js application. So it's going to be a text file that contains instructions for building a Docker image. So this Docker file is a text file that contains instructions for building a Docker image. We're going to talk about Docker images in a bit. It specifies the base image to use, which is, in this case, Python. We're going to be building it, everything on Python. You remember? Oh man, where is it, man? Do you guys remember? Do you guys remember this? So this is what he means by we're going to be building it on Python. That's going to be our base image, right? So Python's a base image and we build on top of it, right? And it specifies additional components to install and specifies custom configurations or scripts to run when the image is built. So obviously we have Python 3.8 Alpine, and we run the pip install Flask. So we have the Flask framework on top of this Python, right? And the environment variables, this is just for your command line. The environment variable will be like Flask app equals app.py, which will be the main application Python script. Exposing the port 5000, and on the command line it's Flask run and host 0.0.00. That's just stuff we need to command it to do so it can run it when we need it to run. So Docker containers. So Docker containers are lightweight, standalone, executable packages. Includes application and all its dependencies. Can be started, stopped, and moved between hosts using Docker engine. Think of it like a mini VM, which I've been saying, since it is where your code runs. And I think the Docker file from previously creates this Docker container. Okay. And now we have Docker image, which is a read-only template. Okay, contains all the code, libraries, dependencies needed to run an application. So the container creates the image, built using the Docker file or downloaded from a public or private registry, used to create container runtimes. Oh right, so ignore me. The Docker file creates the Docker image, which creates container runtimes. Oh, guys, I need to go pray, so I'll be back. It's Asr time. It's been 30 minutes since I've started, so let's go. So Docker image is a read-only template, contains all code, libraries, dependencies needed to run an application, built using a Docker file or downloaded from a public or private registry, and used to create container in runtime. So you know the Docker file we make, that creates an image which creates containers, and we can share that image to download so we can run containers to run applications that we need to run. I hope that makes sense. So I think I messed up before, I explained it wrong. But that was the correct explanation. Have a look at this slide, guys. So here we go. Docker registry. So this is like GitHub for Docker, and you put images on there so you can take those images and run containers. So you can run like, hey, imagine Facebook was an image on this place, right? You could download Facebook and then just run it as a container on your computer. Extreme example, but if you kind of get it, right? You'd get, what's Facebook built of? It's built of like HTML, CSS, JavaScript, PHP. So it would have all those things in a Docker file. It would be on your PC and it would run as a container. Again, Facebook's way too big to put it into a Docker file, but I hope that makes sense. So it's a repository for storing and sharing Docker images. Docker Hub is a public registry that contains thousands of pre-built images, like imagine Facebook image. Users can also create their own private registry, so sign up, guys, sign up. Docker Compose. This is another big element of, oh crap, didn't mean to do that. Big element of Docker. A tool for defining and running multi-container Docker applications. Okay, so you can, like I said, remember that one example where it was like, it wasn't just a one container, it was like two different containers. I have to go back, wait. I'm just lazy, sorry. But that doesn't matter. See that? This blue part is one container, this orange part is another container, and Docker Compose will allow us to manage both of these and make them work together and stuff. Super professional there, Omar. So let's go back to this one. So Docker Compose, multi-container Docker applications, because a container, there's different parts to an application, you know that. So that example I had of Facebook, it wasn't completely correct. Facebook would be composed of like different containers. There'd be like the back end of Facebook, which is like PHP. There'd be the front end of Facebook, which would be HTML, CSS, JavaScript, and they'd be each on their separate container. So imagine the orange part is like the front end, the blue part's like the back end, and Docker Compose would make them both work together to make Facebook, a multi-component application. And it uses a YAML file to define the services, networks, and volumes for the applications. So networks is the services is like any additional APIs, I guess, that would be needed. So like Facebook could be working with Amazon to integrate some kind of shop component to the application. Networks, whatever networks need to be exposed, so we can use the internet to talk to Facebook. And volumes is the data, so where the data is held, so MySQL for example. And it's easy to manage, stops, start, scale, and configure multiple containers using this. It's often used in dev environments to quickly set up an app for testing or debugging. Okay, you can use this command to do that, test and debug, very important. Can also be used in production environments to manage complex applications. So imagine the volumes, you know, the data. You could add more data, increase the volume. Docker Swarm and Kubernetes. This is where I've been stuck actually. And you know, whilst I've been doing it, we're gonna get past it. Two container orchestration tools used for deploying and managing containerized applications. Okay, hope that makes sense. So as they're deployed onto a cloud system, they have to be managed, right? So these two services allow that. They allow you to manage multiple containers across hosts. Yeah. So these containers won't be on one host, they'll be on multiple hosts. So imagine your application, which is you have made Facebook. Facebook won't be on one server, because what if that server breaks down? Facebook is gone. So Facebook will be on multiple servers. So these containers are going to be on multiple servers. And Swarm and Kubernetes make sure these... Okay, if one server with a container goes down, it just boop, use this other one. It's like that, it's that simple. Boop, use that other one. They all share. So imagine one server's like taking the bulk of the load. It can just be like, can you, the server over here, can you take some of this? That's what Swarm and Kubernetes does basically. It's load balancing, service discovery, automatic container placement to make it easy to deploy and manage containerized applications. It provides support for scaling and rolling updates to allow for easy management of large-scale containerized application. Scaling, that's what I meant, what I just described. Extensive documentation and a large community of user contribution. That's great, isn't it, for you guys? Oh my god, it's hard. This teaching thing is hard. So, Docker concepts. Let's talk about Docker concepts. You manage and build. There's a Docker engine which you've installed, which I will teach you to install. There's a Docker file which makes your images, which allows you to do containers. Docker container, which is the VM light, let's just call that. Docker image, which is the thing that gives you the container. Docker registry, which is GitHub for Docker images. Coordinate and deploy. Docker compose, which is manage multiple containers. Docker swarm and Kubernetes, manage multiple containers on different devices. And scaling, load balancing. Registry, this is where it all starts. This is Docker Hub basically. Images, which is, imagine, combination Python, I want Flask on top of it, and it has to be run on this blah blah blah. That's what that is. And the containers run on the PC. Image instance running an app process. So the image running the app in a process, which is a service, a web app, on a container. Cool. Okay, what else is happening? Check this out. So the client, Docker host registry. So we could build using the Docker engine an image to make a container. Go to registry to get the image, and then have the container. Boom, boom. We could pull the image. We could run the image. This isn't that complicated. Basically, us go into here. We do a command. If it has it, if it doesn't have it, if it does have it, that's what all these mean. Like, alright, build it if you have it. If you don't have it, we're pulling it from registry. If we do have it, just run it. Boom, it gets it from the registry. We have the image, it runs on the container. Okay, and this is a Docker demo. Okay, and this is where I come in. We're going to do a demo for Docker. Okay, 1 second. Okay, I'm just going to give you a quick demo of Docker. I don't think you guys have it installed right now, which is fine. We don't need it installed right now. I'm just going to show you like a quick demo of how Docker works. So I'm on my Ubuntu, I'm on my root. Docker run hello world. Boom. What? Image registration. Basically. Where is it? Where is it? Sorry about this. Need to troubleshoot how to ChatGPT we go. Wizardly Dirac. You know what? Because I've been working on this already, don't think this is a good idea. Maybe exit this. We will work on good old Windows. Alright. You know what? I'm sticking with Ubuntu. Screw it. It's too late. Hello. Right, I don't know what's happening here. It's because I'm in this context thing. Docker run hello world, and then I get the error. Oh my gosh. Why am I on this? It's because something we've done later in the course, man. So annoying. Okay, it's fine. of a number of containers in the container images specified in the you know what? Whatever. We're using Windows. I don't care. Right.
Versions for Docker, and then I'm going to open it up, and then when it is, make sure top right, I think up here somewhere. So that's Docker installed. Next up, alright then gang, so when you're working with Docker, I'm going to show you how to do this from the command line as well, but for now let's just run it from here. You can enter inside this interactive terminal, so I could say, for example, a command line interface to interact with that container as well inside as well inside here. So it's going to open up a terminal, so you 0.4, so that's the side 10, and that's going to give me 15, right? Up of half, top of. So next up we'll see, so wrap here, we'll use, so, and then press enter to install that.
Right. We're using good old Windows, so Docker hello world. Wait, what's the Docker run hello world. Sudo Docker run always, because I've not got yeesh. Docker, come on, hey. Great, Docker is on. Right, command line, come on. What's PowerShell? Try and run it as admin. And then it's Docker run hello world. There we go, yes! So as we can see, just created the first container using, so I ran the command and it was unable to find the image on my system, so it pulled it from Docker hub and boom, I got hello world application. It pulled it from its library and that's the program. That's a Docker hello run. I was trying to pull this program and it got this program. Great. If you don't disable, Docker will download the image from Docker Hub, which it did. And this is like the first program everybody runs. If it's not available, Docker will download the image from Docker Hub. So guys, it's good to have two different kind of, I feel bad now for not showing you how to download Docker on Windows, because I'm using Windows now and I feel like I've just wasted everybody's time. I will cut off that part where I told you to download Linux. Your Linux might be fine actually, so maybe you can still do this. But for me, right, wait, Docker download. By the time this video's up, you must have the latest version of Docker installed on Windows. It should be fine. But here we go. Go on the Docker docs, install for Windows. Make sure to do this WSL, Windows Subsystem for Linux, right? Microsoft documentation. Follow these, install. And then after that is installed, this is just nothing. You go on to the store, the Microsoft store, and download a version of Linux that works. So you could download Ubuntu. This is the one I have. Download that, install it, and you'll have Linux environment, and you'll have this. Great. Okay. Let me show you the slide actually. That was the hello world, that's the demo I just showed you. The container will then exit. The command docker PSA shows a list of all containers in the system, including the hello world container that you just ran. The container will have a status of exited. Just check that out, right? And that is exactly what it shows, guys. And here are a list of key commands for Docker, in case anybody's interested. Build, so run runs it, build from a Docker file, pull from Docker Hub, push your image to Docker Hub. PS lists all running containers. For example, this PSA, even the ones that aren't running. Stop, start, remove deletes it, RMI deletes an image, logs shows the logs per container, exec runs a command inside a running container. Great. Docker also has an interactive shell. Say you want to try out a command in an isolated Ubuntu environment, then delete the environment afterwards. First look up docker run help and find the options RMI int. The command we need is docker RMI it. This gives a throwaway Ubuntu environment to try out commands. Let's try it, right? So docker run dash dash rm dash I dash t ubuntu. So it doesn't have Ubuntu, it's going to the Docker Hub, downloading that image, and right now you can see that it's changed to a hashtag and it's got us into a kind of Ubuntu environment. So sudo ls ls. Alright, so this is like the Ubuntu file structure as well. Man, this is really ugly. So we've got boot dev, this is like what you expect to see in an Ubuntu environment. I guess we just exit it, right? Yeah, exit it and we're back into our Windows command line. So you can do this for other stuff as well, you know. You can literally have like need to add Jupyter Notebook previews to your app. Okay, let's do that. Do you wanna, for all the data scientists out there that use Jupyter Notebook, docker run dash dash rm dash p. This is going to be, so rm is like remove it after using it, like before, right? Yeah, it is. P ae 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 Jupyter slash nb viewer. So it's going to find it. It's downloading it. I will figure out every problem with this. Basically, I'm starting from scratch now. I don't have anything on my Windows system, so I'm on the same boat as you guys. I feel like with the Ubuntu thing, I just had so much stuff going on. I didn't really understand what was going on. Kind of made you guys download that VirtualBox for nothing. We're all learning, yeah. We're all learning. Pulled it. $80.80. No. Wait. Where is it? Huh. I think it's localhost. 8080? Is that how it goes? There we go, it works. Yes. And so, because it's on port 880, it's on our localhost, our local machine 880, and we got like our own version of Jupyter Notebook. So here's another example we could do. Let's exit out of this. Yeah, how do we exit? Let's ask our good friend ChatGPT, guys. How do I exit this container? Yep, that's it. And so we just press Control C. Maybe. No. Escape. Exit. I think to stop running a Docker stop. We will figure this out. Why can't I click anything? That's a bit weird. I'm going to create a new one. Docker PS. That's the Jupyter Notebook thing. The name of it is Docker Stop A13A. Is it gonna work? Hey, it worked. Alright, so I use another terminal to stop this one. I don't think that's how you're supposed to do it, to be honest. I think there must be a better way to do that. I think that was very bad. So, Docker PS. And there's no containers now because I've stopped it. And it's removed the container as well. So that's just a way to show that, look, we have that Jupyter notebook and we ran it using Docker. Let's do another one. I'm not going to skip out anything. There's this other one here, Docker volume create name, Jira volume. So this is a volume we're creating with Jira, with Docker. So volumes are that database thing, don't worry too much about it. And yeah, we can create another application, just demoing Docker really. Anything happens, we'll figure it out. What? Gonna ignore that. So let's share some more PowerPoints with you guys. So this is how to install it. Download and install Docker. I think I've shown you how to do that. A Git client, an IDE or a text editor like VS Code. It's not hard, just go on VS Code and download it. Yep, I think I've done that for you. And if it's worked, let's try these commands to see if I was even successful. You know what? Why do I have two? No, I've only got one. Okay. Oh no. Docker -- help. Yay, the help command worked. Git -- help. Yep, I've got git installed code. If I just say code, it's going to give me some next level settings about my PC. Right. This is nothing. But yeah, code works. There's cheat sheets online to help you with just remembering Docker commands. You should use the official Docker website and documentation to help you out, of course. Okay, using the command line and the Docker command to pull the image with that version. Right, let's go. Using the command line and Docker. Okay, let's do that. So, using the with Python version 3.11.2 run an interactive terminal container using the image. Yeah. ChatGPT, guys, lifesaver. Yep. So this will start an interact session inside the container running the bash shell, the name option, specify the name for container. Make it easier, you can refer to the container to run Python code or perform other tasks with the container. To exit the container terminal session, you simply type exit and press enter. So stop the exit container, but it will still be able in the system and can be started with the docker start command followed by the container name. Okay, so let's pull the Python version command. So we're getting a version of Python, and this is going to be a Python image, right? By the way, just so everybody's not super confused, I'm just doing these tasks from the PowerPoint, which is saying, look, find the latest available version of Python 3.112 and docker command to pull it, and use an interactive shell using the image. Okay, so I'm pulling it right now, and ChatGPT showed me the code to pull it, and now I need to use an interactive shell with it, and that shows that docker run an interactive terminal IT, and the name of it is my Python container using Python version image that I've just pulled in a bash terminal. How are you supposed to know this? I'm like a newbie. Okay, still downloading. Yay. Let's see. Yay, and as we can see, got a bash terminal up, and we can do a simple what I forgot how to use Python. What easy thing can I write on this terminal to test? What, print? Oh yeah, obviously. Just check the version. Python -- version, and it shows me the version. Alright, it works great. What is the first line of output you see? First line of output I see is nothing. It's, well, I made this, why not? That's the first line of output. So quiz time, guys. Maybe you can pause the video and see what you got. But here's the quiz elements. What is Docker and how is it different from a virtual machine? What is Docker image and how is it created? What is a Docker container and how is it different from an image? What is the Docker command used to run the Docker container? What is the difference between the Docker PS and the PSA commands? Okay, Docker is more lightweight from a virtual machine. It has a containerized instance of an application. Great. A Docker image is created using a Docker file, which can, yeah, great, that's all you need to know, and that's like a snapshot of the application. And the Docker container is the image being ran on the computer. The command used to run a Docker container is docker run. What is the difference between Docker PS and PSA? So PS lists everything, PSA lists everything that also the things that aren't active. What is the command used to run a Docker container? What is the command used to run a Docker container? Me and ChatGPT are going to do this, guys. We're going to teach you how to use Docker. I'm going to go for a break after this. Bloody hell, I need it. The command used to run a Docker container is docker run. Here is the basic syntax for the command. Docker run. Options, an image, command. I think there's a better example up here actually. Docker run. This is the container. The name of the container. You have to put this flag. Oh, this is the name, and made the name, and this is the image we want to use with bash. Nice. Right. I'm gonna take a quick break. This was easy. This was the easy lecture. But glad I have finished it because I need a break. Boom, episode 1 in the bag.